So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is Apple Redistribution into boxes. So you are given an array apple of size n and an array capacity of size m. There are n packs where ith pack contains apple I number of apples, and there are m boxes as well. The ith box has capacity of I apples. Now then we need to return the minimum number of boxes you need to select to redistribute this n packs of apples into the boxes. Then they have said that note that apples from the same pack can be distributed into different boxes as well. So what the question is saying that you have some apples array and you have some capacity array. This is of size n and this is of size m. Now let's say there is apple 1, 3, 2. And you have some capacity like 4, 3, 1, 5, 2. We are taking this example number 1 to understand the problem statement. Now these are the boxes. So this box has capacity of 4 apples, this box has capacity of 3 apples, this box has capacity of 1 apple, this box has capacity of 5 apples, and this box has capacity of 2 apples. And these are the number of apples that we have. In the 0th index we have 1 apple, then we have 3 apple, and then we have the 2 apples. Now we need to redistribute these apples into these boxes such that we occupy minimum number of boxes. So in the end we need to return the minimum boxes that are required in order to redistribute these apples. So since we need to take the minimum number of boxes, so what can be the solution? Now if you think greedily, what you would do? You would simply take the maximum capacity box first in order to put the apples into it. And yes, this is what we need to do in this question. So we will pick the maximum capacity box first and put these apples according to it. So let me show you with the help of this first example how we'll be solving this problem, so that it is easier to understand then. So yes, let me just take this first example. So it has the apples array as 1, 3, 2, and it has the capacity array as 4, 3, 1, 5, 2. So first of all we need to take the highest capacity box first, right? So we will sort this capacity array. So after sorting, how this capacity array would look like? So we can just redraw this 5, 4, 3, 2 and 1. This is what our capacity would look like. Now we just need to pick these apples and put into these boxes. So what we can do? We can pick 3 and 2, and we can put these apples into box with capacity 5. So this box has capacity 5 and these are the 5 apples, so we can put 5 apples into this 5 capacity. So this is one box that we will need. Then we still have 1 apple, so we can pick the box with capacity 4 and we can just put this 1 apple into box with capacity 4. So in total, to put these 6 apples we require 2 boxes, one with capacity 5 and one with capacity 4. So in total we require 2 boxes, so we will be returning 2. So that's how we are getting the output as 2, and this will be the minimum number of boxes that we will be required, because we are taking boxes in greedy manner, greedy picking of boxes. So if we are picking the boxes greedily with the largest capacity first, so obviously we would be returning the minimum total number of boxes. So this is the solution behind this problem. So this is simple, straightforward, easy problem. So let us just directly look into the code, how we can implement this entire solution in code. So first we are sorting this capacity array in descending order. So R begin and R end. Then we have declared 2 variables, n and m. N as the apples size and m as the capacity size. And then we have declared 2 variables, sum and total. So this total is nothing but the summation of all the apples value. Summation of all the apples. And this sum is what we are going to take while iterating over the capacity array. So let us take this same example, the example 1, and try to see how this solution in like code is actually working. So this is the apples array, and after sorting, our capacity array would look something like this: 4 5 4 3 2 1. So this is the capacity array. So in this case the total would be nothing but the sum of apples array, so it is 6. So we need to redistribute these 6 apples. So we are keeping a sum variable which will keep on iterating on this capacity array and keep the capacity as the sum inside it. Once our sum is greater than this total, what does that mean? That means we have accumulated all these apples, or we have redistributed all these apples into our capacity array with the minimum number of boxes that we are taking. So let us see how it is working. So we are iterating over this capacity array. So first we will be on here. It has the capacity 5, so our sum will become 5. Now we will check whether this sum is greater than or equal to our total. So our total is 6 but our sum is 5. So that means still there is one apple remaining to distribute into these boxes. So we will continue our iteration to the next box. Then we will be coming on to this box 4 with the box which has the capacity 4. So we will add that capacity of I to our sum. So our sum will now become 9. And then we will again check whether our sum is greater than equal to our total or not. And yes, it is greater than total. That means we have accumulated all these 6 apples. We have redistributed all these 6 apples into the box which has taken the capacity as total 9, and total number of boxes that we have taken is 2. So we will break from here, and at whatever index we are breaking this, we will just plus 1 to that to return the total number of boxes, because it is starting with 0 based indexing. So if we end up here, that means we required 4 boxes. If we end up here, that means we required 5 boxes. So if we are ending at this position, that is 5 and 4, so we have taken 2 boxes. So this is the index 1, so we will just return plus 1 to that because it is starting with 0 based indexing. So in total we are taking 2 boxes, and this is how the solution is working. So I hope you understand this problem. Thank you for watching.